Welcome, everyone. Today, we are exploring a fundamental shift in how we build and verify technology. The title of our session is The End of the Era of GUI-Based Testing Tools, Navigating the Shift to Agentic Software Development in the Era of Software 3.0. Before we dive in, let's define a key term, GUI, or Graphical User Interface. This refers to the visual part of software, the buttons, menus, and windows that humans interact with. For decades, testing software meant writing scripts to click these buttons. But as we enter the era of Software 3.0, where AI models drive the logic, this approach is becoming obsolete. We are moving toward a vision championed by Andrej Karpathy, where the focus shifts from manual scripts to Agentic Systems, AI that can plan and act autonomously. My name is Shay Ginsberg. I'm the founder of Vectors AI System. At Vectors, we focus on the intersection of AI and QA. My goal today is to help you understand why the traditional ways of testing are changing and how you can lead this transition in your own organizations. See my profile on LinkedIn at https://www.linkedin.com/in/Shay Ginsberg/. Let's start with the theoretical foundation. To understand why the era of software testing using GUI-based tools is ending, we must first understand the evolution of software itself. I didn't start with ChatGPT. It has evolved since Alan Turing introduced the Turing machine and Turing test, moving from basic pattern recognition to complex reasoning. While the field previously suffered two AI winters in the 1970s and late 1980s due to overpromising, limited data, and weak computing power, a third winter is highly unlikely today. Modern AI relies on vast neural networks, massive datasets, and powerful hardware, GPUs and NPUs. Crucially, AI has transitioned from an academic experiment into a commercial powerhouse, deeply embedded in the global economy, driving high-value sectors like healthcare and software testing, ensuring self-sustaining revenue rather than a reliance on grants. Much of the framework we'll discuss today is inspired by Andrej Karpathy. Andrej is a titan in the AI field, a co-founder of OpenAI and the former director of AI at Tesla. He is widely credited with defining the transition from traditional coding to neural network-based development. Recently, he has been vocal about Software 3.0, a concept we will define in detail shortly. Let's watch a very short video that delves into the implications of this vibe coding phenomenon and how it fundamentally alters the software development and testing lifecycle. To understand the future, we must look at the three stages of software evolution. Software 1.0. This is traditional programming. Humans write deterministic instructions, meaning code that follows a strict if this, then that logic. It is explicit and hard-coded. Software 2.0. This term, coined by Karpathy, refers to neural networks. Instead of writing code, we provide data, and the system learns the logic through a process called optimization. The logic is implicit. It's hidden within the weights of the model. Software 3.0. This is the new era of agentic orchestration. Here, we use LLMs, large language models, AI systems like GPT-4 that understand and generate language as a universal interpreter. Instead of writing code, we use prompts, natural language, to tell the AI what we want. In Software 3.0, the role of a developer changes. You are no longer a writer of code. You are a director of intelligent, fallible workers. Goal delegation. Instead of writing line-by-line code, you define high-level objectives. Orchestration. This is the process of designing workflows where AI agents plan and execute steps. Verification. Because these AI workers are fallible, they can make mistakes. Your primary job becomes checking their work. Software is now built through feedback loops rather than pure hand coding. Why is Gui-oriented testing dying? Because of brittle scripts. A brittle script is a test that breaks the moment a single pixel or button moves in the app. Traditional tools focus on the how, the exact path to a button. But in a dynamic reality, where software updates constantly, this is a maintenance nightmare. We are moving toward intent over path. This means we tell the AI what we want to achieve, the intent, and let the AI figure out how to navigate the UI, regardless of minor changes. This is a transition toward goal-centric test orchestration. Instead of manual maintenance of step-by-step scripts, we define objectives for agents that reason and adapt to UI changes autonomously, allowing testers to focus on risk and system design. The agentic testing loop consists of 4 stages: planning, where objectives are analyzed; execution, performed by agents at machine speed; reporting, which provides deep insights; and self-healing, where the system autonomously repairs flows. As we migrate upward, our value shifts from legacy tasks like manual test execution to cultivating taste and judgment. We focus on system design, building robust oracles and guardrails, because as Karpathy says, you cannot outsource understanding. Managing, quote, jagged capabilities is critical. AI agents can be brilliant but inconsistent, possessing zero inherent judgment. Therefore, human guardrails, active oversight, and rigorous verification of agent-generated outcomes are the new development bottlenecks. What survives of GUI testing? While it is no longer the dominant abstraction, it remains a specialized instrument for visual regression, accessibility compliance, and validating critical user journeys where deterministic behavior is non-negotiable. With the theoretical foundation established, let's move on to Part 2, Practice. In this practical section, we examine real-world examples. First, we look at the login process for a web application, demonstrating how agentic tools can streamline standard testing workflows. We start by generating a comprehensive test plan for the login feature using an AI model. By setting clear objectives, we ensure the agent understands the scope, including positive and negative scenarios, and security validation. Can this entire plan be automated with Playwright? Yes. Playwright is highly effective for modern web interactions and multi-browser testing, though we must distinguish between automating raw execution and achieving deep validation. While Playwright excels at execution, it has limitations. For deep security vulnerabilities like SQL injection, specialized DAS tools are required. Similarly, subjective usability and massive concurrent load testing require their own dedicated toolsets. To implement this, we initialize the Playwright project structure via the command line. This setup allows for quick, repeatable testing environments that integrate directly into our CI/CD pipelines. Here is the code structure for our Playwright test, alongside a simple Windows batch file for execution. This demonstrates the move from complex, manual UI interactions to concise, intent-driven scripts. When executing these tests, the agent handles the heavy lifting, logging results, and verifying the state of the application. This approach saves significant time compared to traditional, brittle test maintenance. Moving to our second example, data integrity validation. Here, we focus on ensuring that backend database states match the UI representations, a common point of failure in distributed systems. By leveraging AI to cross-reference UI inputs with database queries, we can automate the verification of data consistency. This prevents discrepancies that are often missed by simple functional checks. Our process involves building verification agents that compare inputs against expected output schemas, ensuring the system maintains integrity across layers. Verification agents provide automated feedback, identifying mismatches in real time. This reduces the need for manual data auditing and accelerates the feedback loop for development teams. Example 3 covers GUI verification. We utilize AI-driven tools to verify that the visual interface adheres to defined design specifications and remains consistent across different viewport resolutions. By applying visual comparison algorithms, we move beyond simple element presence checks, confirming that the layout is functional and aesthetically compliant with modern design standards. The final example addresses performance and load testing. We use specialized agents to simulate user traffic, measuring latency and system stability under stress to ensure the web application performs at scale. This concludes our look at the practical application of agentic testing. By adopting these methods, teams can shift from manual bottlenecking to scalable, intelligent quality engineering. Moving on to our next practical example, performance and load testing. AI agents allow us to simulate complex user behaviors across thousands of concurrent sessions, providing deeper insights than static scripts ever could. Next, we explore web application testing. This demonstration shows how we move beyond simple click-and-wait automation to testing scenarios that verify the application's business logic and user flow efficiency. For our bug-tracking web application, we integrate AI analysis. This allows the system to not just report failures, but to suggest potential root causes and classify the severity of bugs in real time. We also incorporate bug hunter methodologies. By using automated toolkits, we can systematically scan for vulnerabilities, effectively turning security testing into a continuous, agent-led process. In conclusion, traditional testing tools are becoming obsolete. Their heavy reliance on GUI interactions is a bottleneck that AI agents simply do not need, as they operate at the level of intent rather than pixel coordinates. Agentic testing is here, These AI agents are already demonstrating high proficiency in software testing, and they continue to improve, making them indispensable for modern development cycles. The possibilities are truly endless. We should move away from clinging to legacy frameworks and agile rituals, focusing instead on the future of quality engineering, where we orchestrate intelligent systems. The future of quality is shifting from how to what. The interface for value creation has moved from manual recording to clearly stating behavior and intent for AI to execute. Quality is becoming an emergent property of good intent and rigorous orchestration. Success in this new era belongs to those who master the art of directing AI agents and designing robust, intelligent oracles. To stay updated and continue this conversation, join our community group on Facebook. It's a space for professionals to share insights on the evolving landscape of AI-driven quality assurance. You can also subscribe to my YouTube channel and follow me on Instagram for more content on the future of software development. Thank you for watching, and feel free to reach out via email with your questions.